Good day, students. Today we're going to look at the solution to number 6. Long answer question, part of your chapter 2 sample quiz in book 1 of your Math 1026 booklets. Okay? Now, it's asking us to solve a system of inequalities by graphing. Now, system of inequalities, there are many ordered pairs that can be a solution. So the solution to a system of inequalities is a region. So a full region, okay? And the way we've done these, and we're going to do it the same way today, is we take each inequality and graph it. Okay? So let's take the first one. Y is less than or equal to 3x minus 2. Okay? Now, in order to graph that, we have to make sure it's in the same as y equals mx plus b. It already is. It already has y isolated. Therefore, I have no extra work to do here. I know the slope of this. The slope is the coefficient of the x term, so I'll call m1 3, which of course is 3 over 1, rise over run. And the y-intercept here is, we'll call it b1, is negative 2. So graphing this line. Now, 4 things you got to watch for. You got to decide whether it's a solid or broken line. You have to decide whether you shade above or below, right? And you need the slope and y-intercept. Now, less than or equal to, this sign here, less than or equal to, tells me, because it equals sign, my boundary line is going to be a solid boundary line, not a broken one. Solid boundary line. Okay? B-O-U-N-D-A-R-Y. So solid boundary line. And this also tells me, because it's less than, I shade below. Okay, shade below the line. Okay, so 4 things. Slope, check. Y-intercept, check. We know solid, check. Boundary line, and shade below. Okay, so 4 things for each inequality. Now, let's graph that one before we move on to the second one. So go to minus 2 like we've always done. We've always started with the y-intercept. So here's minus 2 right here. And we go up 3 units. Rise 3, run 1. Rise 3, 1, 2, 3, run 1. Which is the same as going down 3, run 1. They're all in a perfect line. And I'll take my line drawer, solid. I'll draw a solid line through those, hopefully fairly accurately. So roughly right there. Now, we know we shade where? Less than or equal to, so we're going to shade below that line. Okay, so this is the area I shade. So just take your, I'll use a brush here with, let me do it this way, and I'll use a yellow. So this is my shaded, oops, I didn't, you can hit the line if you want, but it's a little sloppy. So let me redo it here. So we're talking about all this area here now, right? Below the line. And you can shade that in with any color. Just to give you, oh, I'm touching the line again, but that's okay. Just to give you an indication, alright? So here we go. I shouldn't go over the line, but I have. I never was a good colorer. Here we go. Alright, now that's the first one. Now you can do that on the calculator to check. So how do you graph inequalities on your calculator? So before we go on to the second line, let's go graph that. Alright, now inequalities is an application. You see apps? See the apps button? So I want you to hit that. Now scroll down till you come to inequalities, or inequalities they call it here. Just for, so keep scrolling till you see, oh, I just passed it, inequality. See that? Now hit enter. Okay, now it's automatically, hit enter again, it's going to take you right to the graphing button, y equals. Now you have 5 choices on the bottom. Equals, less than or equal to, greater than or equal to. And in order to get these, that's these 5 buttons right below it. However, you got to hit alpha first. Okay, so our first one is y less than or equal to. So I'm going to hit alpha, and then I hit zoom, which is below the less than or equal to. Now see what happened? The little less than or equal to sign came up, and it's a little showing shade below. and then you just go over and type your equation. So this is 3, and X button is right there, and subtract 2. And hit graph, and it'll graph that for you. So very similar to what we have. Their axis is a little bit, right? So there's the shaded area. Okay. Now our grid is, their grid is going from -1 to 10, so it's a little bit tighter of a grid. Okay. Now take our second one. So let's go back over here. Let's take our second equation. Now we've got a bit of extra work to do with the second equation. Why is that? Well, let's have a look. We got, let me get my pen going here. 3x minus 2y is less than or equal to 6. Okay? Now, that's not in y equals mx plus b form, so we have to do that. So we're going to take 3x to the other side, right? And I'm going to move it right in here. In other words, I'm going to subtract 3x from both sides. So it becomes negative when you move it over like that. Now I divide each term by -2. Now notice I left out the sign, because when you divide or multiply an inequality by a negative number, you must change the inequality sign. And I'm sure your teacher has discussed that with you in class. So very important. When you divide by, now it doesn't change when you divide by positive, but look, I'm dividing through by a negative number, -2. So I want to make sure I don't forget to do what? Change that sign. Okay, so it's going to come from less than or equal to, it's going to change to greater than or equal to. So now simplify. Y, because they cancel here, greater than or equal to positive 3 over 2x, negative over negative is positive. Positive 6 subtract 2 is -3. So now I know my second slope. I'll write that right here. M2 is what? M2 is 3 over 2. The coefficient of the x is your slope. There's M right there. What is the y-intercept? Y-intercept is -3. Now, check for your boundary lines. Solid or broken? Okay, solid or broken. In this case, it's a solid line again because of the equal sign. So greater than or equal to tells me I have a solid boundary line. And greater than or equal to tells me I shade above. Okay, I'm going to shade above. So putting all that together now, okay, up on our grid we have to plot that. So let me just change colors. Let's go to red. My intercept is -3, so I'm right here for my intercept this time. Okay, and it's a positive slope, so I go up 3, 1, 2, 3, and run 2. 1, 2. Okay, I go up 3, 1, 2, 3, and run 2. Up 3, 1, 2, 3, and run 2. Or I go down 3, 1, 2, 3, and run 2 over here. Okay, so I'm going to draw a line now through those points, solid again. Okay, oops, I'm off a bit there. Let me try that again. Okay, that's a bit better. Okay, now I shade above that line. Okay, I shade above that line. So my, oops, I'm going to bring back my pen, not my line maker. Shade above that line. So it's going to look something like this, above. Right? So there's my overlapping areas. Or there's my two areas. Now where they overlap is the solution. So take a different color and and shade that area. So the solution is the area where the two areas overlap. So this is my solution. Okay? Right there. So shade that with a different color. So where the two areas overlap is your solution. So this shaded red region is the solution. That's the solution to an ordered pair. It's a region. Okay? Now let's double check it on our calculator, see what we get. So I'm going to go back to y equals I'm going to go down to the second one. Now this time it's greater than or equal to, so it's this one over here. So I go to, again, alpha, and I hit graph this time to change it to greater than. See, it changed it to greater than, shade above. And I'm going to put in my equation. It's 3 over 2x. I like putting fractions in brackets in front of coefficients, so I'll say 3 over 2. You could use your fraction button. X subtract 3. And I hit my graph. So there's the first one again. Now here comes the second one. It's shading above. Now where are your two overlapping areas? See it? It's right there, isn't it? So it looks like we did that correctly. Now to confirm we did it correctly, okay, we use what's called a test point. Now, so I'm going to bring back my pen here. Now I'm going to pick a test point that's sort of obvious, right? I'm going to pick one in right there. I'm going to pick that one. Now it's hard to read the graph. I got it all marked up, but it looks like 4, 5, right? It looks like that comes down here to 4 and go across to 5 right here. So I'm going to pick this test point. See what I got done? So there's my test value, 4, 5. I call this the TV test value. Okay, so let's take our test point now and put it back into both originals. Go back to the original equation because you've changed an inequality sign, so it's safer always to go back. So I'll do the first one up here. So I'm checking the 0.45. Do I get a true statement? So y, which is 5, is that less than or equal to 3 times 4, which is x, minus 2? Is 5 less than or equal to 4 3s are 12 minus 2? So do I get a true statement? Is 5 less than or equal to 10? Indeed I do. That's a true statement, so it works in the first one. Now I don't have a lot of room, so come down here to test the second one. The second equation is 3x minus 2y is less than or equal to 6. So again, I'm testing the 0.45, which is in my region. So 3 times 4, which is 12, minus 2 times 5, is that less than or equal to 6? Do I get a true statement? 12, subtract 2 5s are 10. Is that, so is 2 less than or equal to 6? Indeed it is. I have another true statement, so I know I've got the right point, therefore I have the right region, and there's a complete solution for number 6.